So this is the experimental setup for lab number 8, microcontroller looping. When you arrive, you should find the bar graph LED is already in the breadboard, and then there will be these 10 current limiting resistors down here. With this breadboard is set up so that we could use all 10 of these segments. I'm just using the 8 leftmost ones here, so it's just these 8 right here, and those of course are attached through these jumper wires, which you'll need to attach between the anode of each of the LEDs over to pins 2 through 9 of the Arduino board. And then don't forget to also attach this wire, which connects the ground of the Arduino board down to the ground of the breadboard. So once you do that, and once the wires are connected, there aren't too many wires to connect, then we can go ahead and run the programs. So here's lab 08A. It's compiling, and now it's uploading, and this is the behavior that you can expect to see. So it'll just simply go up and down and up and down, and that's really the same behavior that you'll see from lab 08A, lab 08B, and lab 08C. We can expect exactly the same behavior out of those 3 programs, although they are increasingly sophisticated in the way that they're achieving that same behavior. Now lab 08D is going to be a little bit better. It's going to be a little bit more, because we're going to do several things. We're going to do two rounds of the counting up and down, then we're going to do 2 rounds of ping pong, then we're going to do 3 or 4 marquee, and we're going to delay 10 times the standard delay. So let's upload that program, and then what we should be able to observe, here we can see up and down. There's once, there's twice. Here comes ping pong once, twice, marquee, 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 then delay. And then we go back over again. Count up and down twice, ping pong twice, marquee, and then delay. So that's the behavior that you can expect to see out of lab 08D. Now lab 08E is more interesting because it's going to involve random numbers. And I find random numbers to be really interesting. Basically what this does is it lights up a random segment for 1/10 of a second, and then it moves on. It turns that segment off and moves on and lights up another one. You'll notice that about every 100 times there's a second where there's no lights lighting up. And that's when loop has begun to loop once again. We introduce a special extra long delay at the end of each loop, and there's a for loop that is also going to cause the 100 occurrences of the random LED. So there's the 1 second delay. Now we're lighting up 100 random LEDs and 1 second delay, and so forth. Now what you need to do is modify that program so that it will do something a little bit different. Here's the last program that I have. Now what we're going to do is we're going to only do 25 segments, but we're going to keep them lit. So once they light, we're going to keep them lit. This is code that you will write based on the previous example. And you'll notice that after 25 of them, most of the time all of them will light, but every once in a while there's one that will hold out. So it just depends. There's one, oh, it just lit up right at the end. And you can typically see that they'll either all light, or maybe there'll be one that didn't quite light by the time of the end of the loop. So you'll need to modify the random LED function so that it won't turn off the LEDs once they've been lit. You'll need to modify the number of times random LED is called from 100 down to 25. And you'll need to add a loop inside of the main program that's going to erase all of the LEDs every time that the loop begins.